So when doing these, remember that we're multiplying everything in the first parenthesis by everything in the second parenthesis. So for number 1 here, I'm going to start by multiplying x times x, which gives me x squared. And then I multiply that same x by the 5. That way I'm multiplying that first x by everything in the other parentheses. So that gives me a 5x. Now we repeat the process with the 3. So the 3 goes to the x, so that gives me plus 3x. And the 3 also goes to the 5. So that gives me 15. Once we've done that, then we do actually have one more step here because I can simplify this. Notice I can combine the like terms. That's the x's in this particular problem. And so I can go ahead and do 5x plus 3x, which gives me 8x. And just 8x, remember, they have to be the same, so they stay the same after we add them. It stays an x there. And so then that is your final answer. That is now multiplied out. All right, for doing 2 and 3, we do the exact same process. Go ahead and multiply everything in the first parenthesis by everything in the second parenthesis. When you do that, this is what you should have come up with for each. So number 2, you end up with x squared minus 9x plus 14. In that case, in order to get the 9 in the middle, actually the minus 9 in the middle, we're doing negative 7x minus 2x. And then in the case of number 3, you can see we get x squared plus 3x minus 10. We get this 3x in the middle here because we do negative 2x plus 5x, which gives us a positive 3x. Now, I had you do these 3 problems for a very particular reason. There's actually a little bit of a shortcut that we could go through here. There's a pattern involved here. These numbers that are in this expression are related in a very specific way to the numbers in this expression. And it's true for every single one of these problems. All 3 of them that we just did, and actually any of these that you could ever come up with. And notice, if I take these 2 numbers and add them, I get that middle number. If I take those 2 numbers and multiply them, I get the last number. And notice that's true for every single one of these. So like the next one down, notice that if I do negative 7 plus a negative 2, I get negative 9. Or if I do negative 7 times negative 2, a negative times a negative is a positive, that's why it's positive 14. That pattern works 100% of the time with these. And so we can actually make it a general rule. Those of you who like nice general rules that you can follow, write this down to your notes, and we're going to see how we can use this to do something that we couldn't do otherwise. We can now use that information in that same pattern to factor a quadratic. So go ahead and write down this expression, x squared plus 13x minus 30. Now, we go back to our general rule. Actually, before I do that, let me clarify what it's asking. Remember that when we factor something, that introduces parentheses into it. In this case, I'm going to end up with something that looks like this. I'm going to have those 2 sets of parentheses, each one starting with an x. Notice they look like those first problems that I had you do in class today. We're just going the opposite direction. Basically, I'm just giving you those same ones that we did at the start, except we're doing them backwards. So, how do I use that rule? Well, I need to find out what are 2 numbers that add to this middle number and multiply to this last number. So, in this particular case, that specifically means what 2 numbers add to 13 and multiply to a negative 30.
3 and 10.
You've seen problems like this before, haven't you?
Yeah. Why?
It's almost like I was getting you ready to be able to do these types of problems, right?
No way.
I know, it's crazy. Because that's why we've been doing all that practice, especially the stuff that you see on wall map, where it's just saying what 2 numbers add to this and multiply to this. Because if you can do that, then you can factor these quadratics like this. Now, every now and then, though, when you're doing that, you might hit a set of numbers that's just giving you trouble. Because some of you looking at this one, you already know what the answer is, and some of you are going, I don't have a clue. Especially today when I've taken away your calculator. So,
Mine's in my
how can we go about doing it? A great technique for doing these types of factoring problems and finding out what the two numbers are that add and multiply is that you can actually make a table and list out the possibilities. Now, I go to this strategy when I look at the problem and can't come up with the answer fairly quickly. So when I've gone through my first couple ideas in mind and I don't know still after that, then I resort to actually writing them out like this. So that's kind of a general strategy. Now, how do we use this table? I'm going to make a list of every possible combination that multiplies to what I want to multiply to. Now remember what I'm multiplying to here? Negative 30. So I'm going to list out all the different ways I can get negative 30. Now when I do this though, I need to be systematic. I don't want to just start tossing in random numbers, because that's what often gives people trouble. They'll be like, oh, well, I know 5 and 6 give me negative 30. Well, that gives me positive 30. Okay, let's make it negative. And they just start jumping around. And it makes it hard to know if you've actually found all the different values. So I'm going to give you a different strategy here. We go systematically. I'm going to start with 1. 1 times what is negative 30? Negative 30. So it's going to be 1 and negative 30. And I'm just going to go down this list first before I worry about the right side. Does 2 go into negative 30?
Yes.
Yes, it does. Okay, so what's negative 30 divided by 2?
15. Negative.
Negative 15, yeah. So I know that 2 times negative 15 gives me negative 30. Okay, and I'm going systematically, notice. Now I check 3. Does 3 go into 30? Yes, it does. And so 3 times negative 10 gives me my negative 30. 4. Does 4 go into 30?
Yes.
No, it doesn't. And so I skip 4. How about 5? Does 5 go into 30?
Yes.
Yes, it does. Okay, so 5 times what is negative 30?
Negative 6.
Negative 6. And I'm going to keep going through these. Next up, after 5, I'm going to check 6. Can I multiply 6 into negative 30?
Negative 5.
Yes. That gives us negative 5. Now notice in this case, these two lines are different because the signs are different on the numbers. Sometimes you'll do these, like if that were a positive 30, you would get positive 5 and positive 6 for both of them. You would know then I don't need to keep repeating the same thing. All right, but let's go ahead and keep going. So I just did 6. Does 7 go into 30?
No.
Nope. Does 8?
Yes. No.
No. If 4 doesn't, 8 won't. Okay, so 8 doesn't. Does 9?
No.
I think so.
Nope.
10 does. Yes.
Does 10? 10 does, yes.
10 to negative
10 times negative 3. In fact, I can kind of see that now I'm kind of going up through these, right? I did the 6, I did the 10, so that means I got to do a 15 and a 30 still. You could actually check and think through every single number between, but it's only going to be the 15 and the 30 left. So the 15 is times negative 2,
That's a lot.
and the 30 is times negative 1. Now I purposefully chose one to do as this example that gives you a lot of options over here. Because it's the ones that have a lot of options that are probably the ones where you're not going to think of it just off the top of your head. So how is doing this at all useful to me?
Because then you can pick out the 10 and the 3.
Yep, because now I can go ahead and add them up. So like 1 and negative 30 is negative 29. 2 and negative 15 is a negative 13. Hey, is that my answer? Since that's a negative 13, is that my answer then?
But
No,
it's opposite.
because I want it to be a positive 13.
That's why.
So just times by negative 1.
That is absolutely why.
So I just go through and I keep adding those up so I have a nice complete list. And what I'm looking for is, where do I see a combination adding to the positive 13?
Whoa.
And you notice there's my winner. And so then that tells me that my final answer would have to be x plus 15 times x minus 2. Now, some of you, when you do this, you might actually do it slightly differently. You might be thinking about it slightly differently. You might come up with the answer x minus 2 times x plus 15. Is that okay? Yes. Because both parentheses are exactly the same. Notice minus 2, minus 2. All we did was change the order we multiplied them in, and yes, that's allowed. And so either way works. Now again, that's the long way of doing it. You won't have to do many of these the long way. Most of them, you're going to be able to just look at them and pretty quickly think of the right combination. And so, we're going to practice that. We're going to take a look at each of these four and how they would be factored. So on your paper, write down each of these four, and then I'm going to give you a minute or two. Try to factor all of them you can. If there's one where you don't get what to do, leave a spot for you to be able to put it in, because we're going to talk through how to approach them all. All right, first one. Remember that we always add to the middle number, multiply to the last. So in this case, I'm adding to a positive 9, and I'm multiplying to a positive 20. Now, as I approach these, then I'm thinking first about what multiplies. So I think of, okay, what's any two numbers that multiply to 20?
5 and 4.
The first thing that comes to mind is 4 and 5. So then I think, okay, well, what's 4 plus 5? 9. That means I found it with my first guess. So then I do x plus 4, x plus 5. And done. That is the factored form. That's what we're looking for. Now, if it wasn't the first one I guessed, then I would say, okay, well, what else multiplies to 20 then? And again, remember, the order of the parentheses doesn't matter. If you wrote it as x plus 5, x plus 4, same thing. All right, I'm going to go down from there. Okay, so x squared minus 7x plus 10. In this case, I am adding to the negative 7, and I am multiplying to 10. Now wait, so I got to add to a negative but multiply to a positive? Normally, the only way we can think of multiplying to a positive is a positive times a positive. But that obviously won't give us a negative, right? But that's because we tend to forget about the fact that a negative times a negative is also a positive. And so I know my answer actually is going to be x minus something and x minus something. I know both of these numbers will have to be negative. So then I start thinking about, okay, what multiplies to 10? The first thing that comes to mind is 2 and 5, which gives me 7. So if I do a negative 2 and a negative 5, yes, that adds to a negative 7, and yes, it still multiplies to a positive 10, so that works. So final answer there. On to the next one, top right. The one on the top right, though, can sometimes be a little confusing. I see x squared plus x minus 20. What are we adding to here? What is the number
1.
there? Yep, it is 1. So we're actually adding to 1. If it helps you to write it as a little 1 there when you write it on your paper, just help visualize it, that's fine. And then we're multiplying to a negative 20. Now notice I brought the 20 back again. Well, again, when I start thinking of 20, the first thing that comes to mind is 4 and 5. Will that help me here?
No.
Let's take a look.
5 minus 4 is 1.
So I know, of course, every single time we factor a quadratic like this, I end up with the two parentheses, the x and the x. I need to multiply to a negative 20. Well, that means if I'm going to multiply to a negative, that I have to do a positive times a negative. Well, if one of them is positive and one of them is negative, notice if the 5 is positive and the 4 is negative, they add to 1. And so that ends up being our combination. That's what we're looking for. And so the one below it here, x squared minus 3x minus 10, it ends up being approached somewhat similarly. Because again, notice we're multiplying to a negative. And so if I'm going to multiply to a negative, that means I have to have 1 plus and 1 minus. Okay? Well, again, 5 and 2 jump out to me. Are the 5 and 2 helpful this time?
No. Yes. Well, yes.
It looks like actually maybe yes. So I might try 5 and 2 there and see, does that work? Well, it does multiply to negative 10, and it adds to 3. Actually, that's close but not quite there. I wanted a negative 3. So it's a simple fix. I swap which one's negative. And so then, instead of x plus 5 and x minus 2, I make it x minus 5 and x plus 2. Now let's check and see if we got the result we wanted. It still multiplies to a negative 10, but now it adds to a negative 3, so yes, this is what we wanted. That is our factored form there. This is the last set we're going to take a look at. These are special cases where it looks a little bit different. So I just want to remind you how to deal with these kinds of things. Start by writing them down, and then I'm going to talk you through the first couple at least. For the first one, x squared minus 25. We can still use the same process that we were doing before, but the numbers are a little bit different because there is no x term. If this term in the middle, that x term, is totally missing, what does that mean would be in front of the x?
Nothing.
Nothing. A 0, to be specific, actually. When you see just x squared minus a number like that, we are adding to 0 and multiplying to that number. So I'm multiplying to a negative 25. Every single time you see one of these, if we're going to be able to do it, it's going to have to be x squared minus the number. Because if we're going to add to 0, you know the only way to add to 0 is to add the same number by itself, except they need to be opposites. So in other words, like 1 and negative 1 would add to 0. 2 and negative 2 adds to 0. So what would we use for the 25? 5. Because 5 times itself is 25, right? And so it'd be x minus 5 times x plus 5. Or x plus 5, x minus 5, same thing. And so this then is our answer. That's our factored form. It's the two numbers that add to 0 but multiply to negative 25.
Oh, next one's like x minus 4, right?
Okay, now let's go sideways. We're doing x squared plus 8x. In this case, the last term is missing. And so you got a couple options here about how you think about it. One way is you could say, well, it's like having a plus 0 hanging on the end. And so you could say what adds to 8 and multiplies to 0. And that can get you the answer, but it looks a little bit uglier. We've actually done problems like this earlier this year where I said to factor it, and I could have given you this one earlier this year and you could have done it. Because remember that factoring just means inserting parentheses into it. And sometimes that means dividing out of every term whatever appears in every term. And in this case, there's an x in every term. And so I could actually just pull out an x and turn it into x plus 8. I just factored out the x there. Now this is a technique that we talked about earlier this year. I did say you could do it by putting that plus 0 on the end. If you did it that way, the two numbers that add to 8 and multiply to 0 are 0 and 8.
Oh, I just did the 4 times.
And notice x plus 0, that just equals x. So that's why they are in fact the same. It's just a little bit cleaner to write x instead of this whole x plus 0 thing. So that's why I don't worry about doing it that way. All right, with that in mind, go ahead and now do the bottom two.
Okay.
Because they follow the same patterns as those two we just did. So for the x squared minus 81, we know that if we're going to add to 0 that we have to have one of them being plus and one of them being minus. We also know that because we're multiplying to a negative. And so we say what two numbers add to 0 and multiply to negative 81. And it's 9 and negative 9. So there's your answer for that. Then, for the last one, whether you do it as thinking of it as what adds to negative 11 and multiplies to 0, or whether you think of it as factoring out an x, you should end up with the same thing here, x times x minus 11. Now, a little side note before I let you loose here on a little bit of practice on your own. All of these problems over here on the right side, these two problems, these we're going back to the older scale. We're not going to be practicing those much right now because we're going to be practicing, of course, the brand new stuff more. But I did want to at least bring those back and remind you that that's a possibility, that we can look to see what can I divide everything through by before we get rolling. The last thing I'll mention here is, since I told you today I want you to do all these without your calculators, that means you're having to rely on your knowledge of your times tables. And a few of you struggle with remembering your times tables. Two things on that. One, practice them. This is a nice opportunity to actually practice them to the point where you get better at that. Because the better you know that, the better off it's going to be for you in every math class you ever take, and in the real world where you have to do calculations off the top of your head. The better you know those, the better off you're going to be. And so, how do you get better at them through this process today? Well, you're going to be practicing a lot. And I'll go ahead and give you a times table that you can check on if you ever need to look and see, wait, what multiplies to this again? And you can use this as a way to look and see and remind yourself, what does multiply to this given number?